All right. So the next topic is the triple integrals. So normally, problems will be in this format. So you have three integrals to be solved, right? One for x, one for y, maybe one for z. You may have a function containing x, y, as well as z. So since the innermost integral is z, so you will do dz first, then dy, then dx. Okay, right? So that's the very standard format. Like it's just an extension of double integral to triple integral with the similar rules. Okay, so let's start solving some of the problems just to get adjusted to the integration process. All right. So the first one, I is equal to integral 0 to 1, integral 0 to root of 1 minus x square, integral 0 to root of 1 minus x square minus y square, x, y, z, dz, dy, dx. Okay, so like every problem we solve for it in case of a double integral, we just have to add one more integral to that. That's all. That is with respect to z. All right. So right, let's start solving. So this is equal to, I will do the innermost integral first. So other two remain as it is. So that is integral 0 to 1, integral 0 to root of 1 minus x square. Right. So the terms x and y are untouched. Only z is replaced as after integration z square by 2. So should substitute from 0 to root of 1 minus x square minus y square. This is dy dx. Okay. Now I'll substitute this. So this is integral 0 to 1, integral 0 to root of 1 minus x square, right? When I substitute, okay, let's write the xy as it is. Then let me substitute. So when I square and substitute, this becomes simply 1 minus x square minus y square minus z becomes 0. So that is a 0, right? And there is a divide by 2, right? I can write it over here for the time being into dy dx. So what I do in the next step is that I'll try to write the half outside. So this is 1 by 2 into, now I will actually multiply them and maybe then I can do the integration. That should be easier for me, right? So that is integral 0 to 1, right? Integral 0 to root of 1 minus x square. So I will multiply. So the first term is xy minus x cube y. Sorry. Next term will be x y cube dy dx. All right. So in the next step, this is equal to 1 by 2. I just keep this integral on, that is 0 to 1, and I'll integrate now with respect to 1. Okay. So that means x y becomes y squared divided by 2. Okay. Then we have a minus integrating with respect to y. So x cube as it is, y becomes y squared divided by 2. Then we have minus x as it is, y cube becomes y to the 4 divided by 4. All right, substitute that y is equal to 0 to root of 1 minus x square. Still, we have one more integration to be done, that is with respect to x. So write a dx over. Okay, then this is equal to 1 by 2 integral 0 to 1. I need to substitute y square, sorry, y is equal to root of 1 minus x square, right? So let us substitute that, right? Okay, I prefer doing one thing, that let me take out denominator first, otherwise that's going to be uh, difficult for me. That's what I think. I'll take a 4 outside. Okay, so that means this is 1 by 2 into the 4 comes out. Let me write that as 1 by 8. I'll take 4 outside from the denominator, so that is 1 by 8. Then I'll write the remaining terms inside. So 2 means I have to write a 2 first. So this is 2x y square minus 2 times x cube y square. This step is optional. Okay, you can skip this also, no problem. X y to the 4, still to substitute 0 to 1 minus x square dx. So that means in my next step, this is equal to 1 by 8 integral 0 to 1. So I substitute like root of 1 minus x square over there. There is a 2x already present. Y square makes this as 1 minus x square, right? Then I have minus 2x cube already present. Y square is 1 minus x square, right? Minus x as it is. There is a y to the power 4, so that is 1 minus x square, which is y square, its square, dx. All right, so that means I need to simplify this further before I do the integration. So 1 by 8 integral 0 to 1. Let us try to multiply the terms and write. So 2x into 1 is 2x, minus 2 times x cube minus 2 times x cube, minus of minus is plus 2 times x to the power 5. Okay, let me do this calculation separately, and then directly let me write the answer. There is 1 minus x square, right? Whole square. So this is 1 plus, do you have x square whole square, right? So this is 1 plus x to the 4 minus 2 times the x square, right? Into x is there, so I have to add another x here. So this into x, right? So it becomes minus x. There is a minus x outside, so minus x into 1, it is minus x. Then minus x into plus x to the power 4, that makes it minus x to the power 5. Then minus, this becomes plus 2 times x square into x is x cube, right? So this into dx. All right, so this is equal to 1 by 8 integral 0 to 1. Let's try to simplify this. So let me write the highest power. 2x to the power 5 minus x to the power 5 becomes simply x to the power 5. Right? Then we have x cube term. So one of the two x cube will cancel with this. So there is minus 2 times x cube. Then plus 2x minus x is plus x. Dx becomes a very simple integral now. So this is equal to, okay, 1 by 8 x power 5 is x to the 6 by 6 minus 2 times x to the power 4 by 4 plus x square by 2, 0 to 1. So this cancels. Adds 2. So this is 1 by 8. Substitute 1. So this becomes 1 by 6 minus 1 by 2 plus 1 by 2. So we'll cancel them. 1 by 8 into 1 by 6. 1 over 48. Okay. So that is the expected answer. All right. Let's move further. Next question. This is I is equal to, again, this is from, this is a repeated question. So I is equal to integral 0 to log 2 integral 0 to x integral 0 to x plus log y e to the power x plus y plus z dz dy into dx. So okay, we'll try to write in this way first, so that okay, this is 0 to log 2 integral 0 to x. This is integral 0 to x plus log y. We'll write it in this way. We'll split x plus y into e to the z. Okay, so dz dy dx, out of it e to the z dz I can substitute, right? So e to the z dz is e to the z itself, right? Because we are integrating with respect to z itself. So that means this is equal to integral 0 to log 2 integral 0 to x, right? Then I don't write the third integral. I'll write the result of integration. This is x plus y. E to the z is e to the z itself, but I need to substitute 0 to x plus log y. All right, this is dy dx. Right, so this is equal to integral 0 to log 2 integral 0 to x. Now after the substitution, so we have the e to the x plus y as it is, right? When I substitute this, e to the power, okay, this is the substitution for that. This is z is equal to x plus log y and z equal to 0. Z equal to 0 means it is 1, right? Right, so we have dy dx. Right. Now, let's do a calculation somewhere here, right? So we have e to the power x plus log y. So definitely you can write this as e to the x and e to the log y, correct? So e to the log y is nothing but you are taking e to the power and you are taking a log of that they are inverse operations of, right, each other, right? So it is simply y, correct? So this can be written as e to the power x into y. That's the problem. So we use this, right? So instead of writing the whole integral again and then substituting, let's do this. Okay, so that's why I wrote it separately in a column. So that means this is what is going to happen now. So this is integral 0 to log 2 integral 0 to x. So we have I think we can even separate these terms into the x plus y. Uh, okay, so let's do this. So that is e to the power x plus y, or okay, let's see how it proceeds. I think better to split this now itself. Okay, instead of splitting later, let's split this, because anyway ultimately I'm going to do the integrations after separating. So let's separate. So this is e to the x into e to the y, I'll write. Then I'll write what is inside. This is e to the x multiplied by y minus 1, correct? dy dx. Okay, now I think I can multiply the terms, right, before I do the next step. Log, this is 2. Yes, this is 0 to x. So now I'll write the term e to the, correct, e to the 2x into y into e to the 1, correct? E to the 2x, y into e to the power y minus e to the x e to the y, right? Uh, I think maybe what I can, it was already outside. I actually multiplied this. Because what I'm thinking here, what happens if I try to integrate with respect to y e to the y is a product. I can integrate that as, keep the first function as it is, integrate the second minus. I can actually integrate the this by integrating by parts. I think I have an answer here. So maybe this works fine. Just see. Let's see. Okay. So uh, this I'll still write dy dx. Next step I'll do the integration dy dx. Now let's see. So this means in this step I have to integrate with respect to y, because y is integral is inside. So 0 to log 2, I do the integration. See, the e to the 2x is constant for this, so I keep it as it is. Now you see y e to the y. Y e to the y means it is integration by parts. Keep the first function y as it is. Integrate the second function, which gives you e to the y, okay, minus differentiation of y, which is 1, into the second function as it is, that is e to the y. I hope this is fine, right? Product rule. Okay. Minus, so e to the x as it is, e to the y integration is e to the y. Okay. Substitute the limits 0 to x dx. So only because I have y e to the y, this method worked for me. If at all it was something else, maybe I should have yeah, okay. This method will not work in case of any other product. Okay, fine. Then I just have to substitute now. So this is 0 to log 2. Let's substitute x over there. Then y is equal to 0. So when I put x, let me take, this is e to the 2x as it is. So substitute over there as this one. So first you put, this is x e to the x minus e to the power x, right? This is what happens when I put x over there. I should subtract whenever you put 0 over there. So first term is 0 minus uh, e to the power 0, that is 1, correct? Right, so that's the first part. Then minus e to the x as it is. So I think I can put e to the x, we'll take it outside. Then let me substitute. Put x over there, e to the power x. Put 0 over there, e to the 0, which is 1. I think this is right. Okay. Right. So substitution is over. Still dx limits. Okay. Then this is equal to, we will try to simplify. This is integral 0 to log 2. Let us try to multiply the terms. So there is e to the 2x into x into e to the 2x. So that becomes x into e to the 3x, correct? the first term. Then e to the x minus e to the x into e to the power 2x. So that is minus e to the 3x. All right. Then e to the 2 minus of minus 1 becomes plus 1. So this is plus e to the 2x. Right. Then minus e to the x into e to the x is minus e to the 2x. The last term minus e to the x into minus 1 is plus e to the power x. Right. I think this becomes easier now. So this has to be equal to, can we simplify further? Yes, e to the 2x, e to the 2x will cancel. Minus 2 e to the 2x. So e to the x e to the 3x minus e to the 3x plus e to the x. Only those are the remaining terms. We'll directly do the integration. Okay, so integrating 0 to log 2 of, I'll write once again, x e to the 3x minus minus e to the 3x plus e to the x, right? Okay, dx. So this is equal to x e to the 3x. Once again, the product rule, right? Keep the first function as it is. Second one, e to the 3x by 3 minus, right? So x becomes the same. Second one, I need to integrate again. That means it is e to the 3x divided by, already there is a 3, one more 3, so that is 9. Okay, then other terms will be same. So this is minus e to the 3x by 3 plus e to the x, right? So 0 to log 2, right? Can we simplify this? E to the, there are so many e to the 3x, right? Can we club x e to the 3x? No, let's keep the first term as it is. Before we substitute, let's keep this as it is. X into e to the 3x by 3. I'll keep this. These two I'll try to club. Okay, so this second one gets 3 divided by 9. So 3 minus 1 is 4. So you can simply write this as minus 4 into e to the power 3x divided by 9. Correct? Plus e to the power x. So now you substitute 0 to log 2. So this is equal to, let us substitute. That is log 2 into e to the power 3 times log 2 whole divided by 3. Now we put 0 means it is, x is 0, so irrespective of other values it cancels. Okay, that's the first term. Then minus, I'll write the 4 by 9 outside, then I'll substitute, right? So this is e to the power 3 times log 2 minus, put 0 over there, e to the 0, which is 1, right? And we have the third term, that is simply plus, I think I can write e to the x, so that is log 2 minus e to the 0, which is 1. So how do we simplify this? So e to the 3 log 2 is e to the 3, and we have e to the log 2, so it will cancel, it is simply 2, correct? So there is a log 2 as it is, we'll split this. So this is log 2 into e to the 3, correct, into e to the log 2 whole divided by 3. Okay, or okay, there is easier way. Sorry, I missed that. See, 3 log 2 can be written as how do you write 3 log 2 can be written as log of 2 cube, right? So this is log 2 into e to the power log 2 cube. So that e and log will cancel, right? So I can simply cancel this whole divided by this. Okay, let's apply the same thing everywhere so that this becomes easy. 4 by 9. So this is e to the power log of 2 cube minus 1. Once again, e and this will cancel. So plus here e to the log 2 is simply 2 minus 1. I can directly substitute there, right? So that's okay. So this is equal to, I have log 2 into 2 cube, isn't it? Because e and log cancel, 4 divided by 2 minus 4 by 9 by 3 minus. Yes, I'm correct. So this is 3. 4 by 9 into, this is a 2 cube minus 1 plus this is 2 minus 1, that is 1. Okay, right? So let us substitute. This is 2 cube, that is 8. 8 log 2. Anyway, we can substitute the log 2 also, but let's keep this, no problem. By 3 minus, so this is, yeah, sure. Okay, so then I substituted 4 by 9 into 2 cube minus 1, that's 8 minus 1. I think we cannot further reduce the first term. Okay, we'll keep this as it is. 8 log 2 by 3 minus, now 8 minus 1, 7. 7 into 4, that is 28 by 9 plus 1. Okay, so this is, I can write 9 minus 28 plus 9 is minus 19, minus 19 by 9. So that should be the last answer. So 8 log 2 by 3. Uh, 8 log 2 divided by 3. So this is minus 28 plus 9 is 19. Maybe we can use a calculator to simplify and forget an answer. Yeah, that's fine. I think we can do it. Okay. Okay. Sure. No problem. If you need some time, you can take it. No issues. Okay. The next question here is solve. I is equal to, this is 0 to 1, 0 to root of 1 minus x square, 0 to root of 1 minus x square minus y square. This is dz dy dx divided by under root 1 minus x square minus y square. Oh, this is also under root square root here. Okay, square root, and this is a square. Looks like pretty complicated, but right, actually a easy answer, right? Z square. So right, there is a bigger square root, and inside that I have a square term, and within the bracket I have root of 1 minus x square minus y square, then subtract minus z square. Okay, yeah. So please try to solve this. Then we'll discuss the answer. What we are going to use is this formula. If you have an integration of something like maybe dx divided by root of a square minus x square, if you have any this whole thing, it is replaced by simply the answer of integration is sine inverse of x by a. That means you don't have to do the this whole term is there, right? So this is what is the answer for this will be sine inverse of something, sine inverse of z divided by root of 1 minus x square minus y square. Possible. That's why I told you. It looks like pretty complicated, but one step it becomes nothing. All right. Yeah. Please proceed.